Hello, welcome。我是许文正，国立高雄科技大学现在开始进行 micro teaching。So welcome to the class of automation engineering. This is the outline for this introduction. A. The introduction and the self-introduction of the lecturer. Point 1. Previewing the main topics including objectives, instructional methods, and the grading system, and also the regulation rules in the classroom. To the self-introduction, I'm Dr. Albert Wenjun Xu from National Kaohsiung University of Science and Technology. The web page of my laboratory is listed here, and my academic background including the PhD program from mechanical engineering at the National Taiwan University, and my master degree is also from the mechanical engineering at National Cheng Kung University, including several experience in industries, and my email and office hour is also listed. B. Instructional methods, including lectures of about 12 weeks and the laboratory for 6 weeks, and the experiment equipment including programmable logic controller is so-called PLC, and notebook PC, and automation mechanisms. So hope that will provide you a comprehensive understanding and useful practice in your learning semester. C. Assessment and grading system is divided into 4 quarters. As shown in these slides, the grading system includes the midterm, final term, and attendance with participation. And the other quarter is about the homework and the reports. So classroom regulation, time and place is that we will meet once a week on Wednesday at the lab of MD 514. Homework and the reports must be handed out in the lab on the due date, and no food and beverage are allowed in the classroom except the necessary reason. Let's move on to the main topics. Topic 1, system and control. The process, also called a system, is to be controlled with input and output. So the definition of a system or a process is a combination of components with a finite boundary to be clearly observed from its input and outputs. And the control is meant to manipulate from the input to output. So we can through an actuating devices to contribute the control effort. For example, from manually operation to automatic control, as we can see from left, a manual control of water level from the water supply pipe. A man can manually check in with the eyes so that we have the ability to turn the valve and to control the output flow of water. So it is a system here from input to output, and the system to be controlled is called a process. This is a water level control system. B. Automatic control of wheel speed. As we get the steam from the boiler input to the system, we can control the valve to manipulate the steam flow into the engine. So that the engine is an actuator that will activate our motion, for example, a train's wheel. And after that, we can measure the rotation speed through the flyball governor. So this is a rotary speed control via a flyball governor, and this formed automatic control of wheel speed. And the second topic about the open loop and closed loop control. The classification of modern control systems include A. Open loop control system. A control is a serial action to make system output adhere to a reference value, that's so-called input, to a desired level. Either a constant or variable output may be conducted. That will be regulation problem and tracking control problem respectively. And an open loop control is a straightforward path besides the serial control actions, where the information from the system output does not affect the decision of its action. For example, the control of pitch movement in the basketball game. The reference value represent the desired location and speed of the basketball. However, the pitcher make decisions from his brain, and the actuator means the fingers, muscles of arms, etc. And as he pitch the ball, some kind of distance, for example, the windshield, may affect the location and the speed of the actual basketball. However, as it is a straightforward path, the output of that ball does not affect the decision of its action. B. Closed-loop control, or so-called feedback control. In control, some disturbance, for example, as we mentioned, that the wind for the basketball, that may be from the outside of the system, unexpectedly, randomly, and suddenly appearing, cause severe problems to the system output. So we need an output control, output loop control. That means actions to make system output adhere to a reference value with information measured from the output and compared with the reference input. So control decision is based on the output through sensors here, and is some kind called feedback control. For example, the control of intake water level by human. How did we conduct water level intake into the glass cup? Maybe we need to take a look at the water level and manipulate to decide which level of the water is enough. So we need to compare the reference the desired level with the sensor's output. That will form a closed loop. So the difference between open loop and the the closed loop control is shown here. For open loop control, the controller is constructed based on the knowledge or experience. This process output is not used in the motion in the computation of control strategy, so-called feed-forward control. On the contrary, for feedback control, the output is fed back for the control computation. As the water level control of our flush toilet, as the floating point get higher enough so that the heavy valve will cut off the inlet of the water. However, as the water drain out, the floating ball will get lower and lower, so that from this mechanism with pulley and strain, the valve will be pulled upper and upper, so that the inlet of the water can get refilled into the toilet box or toilet tank. So let's see some kind of demonstration of the famous Ashimo robot. For example, Ashimo robot once conducting a symphony orchestra in Chicago, and in the other slides, the Ashimo running at 3 km/h speed. Let me make a joke phrase. I did also invent a superior robot more beautiful than the Ashimo at home. Let's meet my adorable daughter, Erya. And question 1, is Ashimo's action be controlled by an open loop or a closed loop scheme? Please answer in a Slido system. Okay, because the Ashimo needs so advanced motion, obviously it needs a closed loop scheme. And the second question, what's the component of Ashimo according to the Kreis term? I mean the input output, and what is his controller, what are the sensors and the actuators. As we mentioned above, the Ashimo use a lot of components, and please try to divide it or classify it into 6 components categories. For example, some hint for referential understanding. The power and the command for direction, position, and angle and speed must be taken as input. For example, the output include the head motion, arm motion, leg motion, etc. Also including speech and display and the gripping of his fingers. Third, about the controllers. In Ashimo, there must be a central computer. It may be made of a CPU or some kind of distributed board, including digital signal processor. It's also called DSP. Fourth, the actuators may include motors, pumps, and speakers and displayers. Sensors may include force sensor, angle gyrometer, image sensor, for example the video camera, or voice sensor, for example the microphone. And 6, the major signal may include some kind of voltage, current, and even the force. And interesting enough, furthermore, please try to discuss what may be the unexpected disturbance to a straight walking Ashimo. When Ashimo takes a straight path, walking along a straight path, what may be the unexpected disturbance to him? Please take 5 minutes to discuss this. And we will invite each group to report your discussion. Okay. And finally, let's get some summary. What is the control? Control is a series of actions directed for making a system variable adheres to a reference value. That value can be either constant or variable. If it is constant, it is called a regulation problem. If it is a variable, it is called a checking control problem. Second, the reference value when performing control is a desired output variable. Third, a process as it is used and understood by control engineers means the component to be controlled. Fundamental structure of control are classified based on the information used along the control process. If we did not use the control output as an information to make any decision, it is an open loop control, also called the feed-forward control. If we use the real-time output and compare it to our input, so that's a very good information for our control decision. It is called a closed loop control or a feedback control, as here. Since this is a closed loop, okay, so we sometimes call it a closed loop or a feedback control. Summary 2, components. We have mentioned about the system inputs, outputs, and the controller, actuators, sensors, and major signals. As we can see from the block diagram. And more importantly, maybe some disturbance in Chinese, say we can call it 干扰. from the outside of the system that will contribute to the need of the closed loop control, because only closed loop control can reject the disturbance, but the open loop control will be helpless when he faces this disturbance. Homework 1. What has happened to our daily life with the closed loop control devices? Please make a report with a paper with A4 paper to describe the need, idea, design, implementation, and the results in 5 to 8 pages in 12-point forms, with your student number and your name on the cover paper. For example, water level control of the flush toilet, as mentioned above. And as a quotation from Elon Musk, Tesla robot taxi will be like Uber and Airbnb combined in the near future. And actually, industrial robot is emerging and widely adopted in situ of production lines and security monitoring in recent years. So this is the first class of our introduction to automation engineering. Welcome all students. Please hand out this homework on due date on time in the next week. Okay, goodbye.